work done will be equal to the change in kinetic energy, which is final kinetic energy minus initial kinetic energy. Final kinetic energy is 0 since the object is coming to rest. Initially, they have given is 10. So delta K will come out as negative 10. This will be the total work done. Now, to figure out the total work done, we have to first figure out what is the net force which is acting on this object. So how do we do that? Let's draw the free body diagram. So the first force will be the weight of the object which is acting downwards, which will be balanced by the normal reaction provided by the surface going in the upward direction. Also, there is a frictional force which is trying to oppose the motion of the object acting in the leftward direction. Now, normal reaction and 2g, the weight, will cancel each other out. So the net force acting on the object is only friction. So the work done, let's write down the basic formula Fs cos theta. F is friction, displacement is 3 meters, and the angle between the frictional force and the distance is 180 degrees. So cos 180 will come out as negative 10. So the value of friction according to the formula is mu times the normal reaction, and normal reaction is m into g. So let's write down multiplied by 3. Cos 180 is negative 1. So negative sign will get cancelled out from both sides. Continuing ahead, mu times the normal reaction mg multiplied by 3, minus sign gets cancelled out. So we get a 10. Now, since we have to find the coefficient of dynamic friction, let us make mu as the subject. We will get 10 upon 3 mg, and mass of the object is given as 2 kilograms. So let's write down 10 upon 3 into 2, and the value of g we can take as 10. So 10 and 10 gets cancelled out. Hence, we get the value of mu as 1 upon 6. Hence, option A is the right answer for this question. We could have also solved this question using the Stewart equations, which are also called the Newton's equations of motion. And how do we do that? Let me write down the third equation, which states that v square is equal to u square plus 2as. Final speed is 0. Initial speed we don't know, but we can find it out. So the initial kinetic energy is 10 joules. So let's write down half m u square is equal to 10. Mass of the object is 2. So half into 2 into u square will come out as 10. So u square will be equal to 10. So directly we can put this value of u square in this equation. So we write 0 is equal to 10 plus 2 times acceleration, and the distance traveled is given in the question as 3. So if we make A as the subject, we will get acceleration as negative 10 upon 6. Now, what do we do after this? So we have to find the same acceleration but using another formula. So let's use the Newton's second law. F net is equal to ma. So acceleration will be net force divided by m. And we already discussed the net force acting on the object is only friction. Now, since the weight and the normal reaction are cancelling each other out, friction is the only resultant force. So the net force is friction. We have to divide that by mass. So the value of acceleration will be friction is mu times the normal reaction divided by m. In this case, normal reaction is equal to m into g. So m gets cancelled out. So we get acceleration as mu into g. Now all we need to do is equate this value of acceleration to the acceleration which we got earlier. So we will write mu into g. We can ignore the negative sign. So we will write 10 upon 6. G is 10. So g will get cancelled out. Eventually, we get the value of mu as 1 upon 6, which means A is the right answer. Now, bear in mind why we have ignored the negative sign, because in this formula, we have used the magnitude of friction. So the net force is equal to mu times n, which is the magnitude. And over here, 10 by 6 is the magnitude. That is why we ignored the minus sign. So A is the right answer to this question. A box of mass 2 kilograms is pushed and released with an initial speed of 10 meters per second. So let's draw that. It is moving on a rough horizontal floor. A uniform frictional force of 10 newtons acts on the box. So let's draw. Friction will oppose the motion. So in this case, we can draw the direction of friction to be left. The question is, what is the distance traveled by the box at the instant when the kinetic energy of the box is halved? So let's use the work energy principle to solve this question. We can also use the Stewart equation to solve this. So the change in kinetic energy will be final kinetic energy minus the initial kinetic energy. Initial kinetic energy is half m into v square. Now mass of the object is given as 2 and the speed, initial speed is 10. So eventually we can write initial kinetic energy is 100 joules. So in the expression, we will write kinetic energy initial as 100. Now the final kinetic energy is half of the initial. So half of 100 is 50. So final kinetic energy will be 50. 50 minus 100 comes out as negative 50. Hence, the total work done by forces acting on this object is negative 50 joules. Now to find the work done, we already know the formula Fs cos theta. So Fs cos theta. So what is the net force acting on this object? So the weight of the object will be balanced by the normal reaction. So let me write 2g, which is the weight, will be balanced by the normal reaction. And that is why friction will be the only resultant force acting on this object. So instead of force, net force, we will write friction. Displacement is what we need to find. Angle is 180 degrees. And why it is 180? Because friction is leftwards and the object is going towards the right. So angle is 180. This will be equal to negative 50. The value of friction is given as 10. So let us write 10 multiplied by d multiplied by minus 1 is equal to negative 50. Cos 180 is minus 1. Minus minus signs will get cancelled out. Eventually, we will get d as 5 meters. And that is why option B will be the correct approach. And that is why option B is the right answer for this question. Now, we could have also solved this question using the second method, which is the Stewart equation or the Newton's equations of motion. So let's write down. Let's call it as method number 2. So let's write down the equation. V square is equal to u square plus 2as. Initial speed is given as 10. So we will write 100 in place of u square plus 2 times the acceleration multiplied by d. And d is the distance which we want to find. So initial kinetic energy was 100 joules. So final would be half of that 50 joules. So we can write down, since final kinetic energy is 50, let's write down half into mv square will be equal to 50. And mass of the box is 2 kilograms. So if we simplify this expression, we will get v square as 50, which we can use in this particular expression. So v square can be written as 50 equals to 100 plus 2 into acceleration multiplied by distance. Let's simplify this expression. So we can write 2ad equals to negative 50. Hence, a into d will be equal to negative 25. And since we have to find the d distance, let's make d as the subject. We will get negative 25 divided by acceleration. And how do we find this value of acceleration? We are going to use the Newton's second law, which is F is equal to ma. So acceleration will be the net force divided by m. Net force acting on this object is only friction, which is 10 newtons in magnitude. So the net force is 10, mass is given as 2, which means acceleration comes out as 5 meter per second square. So we can use this value of a in this expression. So let us write down d will be equal to 25 divided by a. We can ignore the negative sign. So 25 divided by 5 will come out as 5. Hence, the value of d is 5 meters, which was option B. So here we have a box of mass 2 kilograms starts to move on a level surface under the effect of a varying force F. The variation, so the graph is given. X-axis is displacement, y-axis is force. So we need to figure out the speed of the box at a particular value of s, which is 5 meters. So let us try to solve this question using the work energy principle, which states that the total work done is equal to the change in the kinetic energy, which is equal to the final kinetic energy minus the initial kinetic energy. Now, initial kinetic energy of the object is 0 since it is mentioned that the box starts to move. So, initial speed is 0. So, initial kinetic energy we can write as 0 and final kinetic energy is half m into v square, where mass is given as 2 kilogram. So, how do we figure out the total work done? Now, we cannot apply the formula for work, the basic formula Fs cos theta. That formula is not applicable because the magnitude of force is not a constant. It is constantly changing. So that formula goes out of the window. So what do we do in such cases? We have to figure out the area under the graph. Step 1, let us draw a dotted line from the end of the graph on the displacement axis. So in this case, it is the x-axis. And then let us shade the entire region. This entire region's area we need to figure out because that is equal to the work done. So how do we figure out this area? Let us divide this entire region into two separate parts. One will be a triangle and then we have a rectangle. So over here you can see a rectangle where the length is 5 meters and the base height is 2. So the area of the rectangle will be 5 multiplied by 2, which is equal to 10. So we can write 10 over here. Now considering this triangle, the base of the triangle is 5, but the height will be 8. So over here this is 8. Just for clarity, let me show the dotted line. So this is point 0.8 and point 0.2. So the height of the triangle will be 8 minus 2, which is 6. Hence, we can say the area of the triangle will be half base into height. Base is 5 and height is 6. So we write this as 15. Area of the triangle will become 15. Hence, the total area of the entire region will be 15 plus 10, which is 20.